So the second part of compositions we're going to take a look at is when we're going to look at, instead of using numbers, we're going to use the function instead. So you guys did this last year, and this was probably the trickiest part to get used to. So I just want to say, like, if we had, I'm going to write something on the side here. You know, if we had f of x equals x plus 5, and we said f of 2. Do you guys agree you'd have 2 plus 5? F of 4 would be 4 plus 5. F of 6 would be 6 plus 5. If I had f of w, do you guys agree that would be w plus 5? If I had f of p, you'd say p plus 5. Now if I had f of p plus 2, do you agree that'd be p plus 2 plus 5? And a lot of times when you substitute something, it's a little easier to see if what you substitute you put in parentheses. So if I had f of w plus 3, that would equal w plus 3 plus 5. So we're, instead of substituting numbers, we're going to be substituting in some letters, an entire function. So let f of x equals x squared minus 1 and g of x equals the square root of x. Find the function h of x that is equal to f of g of x. So I'm going to take this entire g of x function and plug it in. So this is really f of the entire g of x, which is the square root of x. So if I plug that into my f function, it's really the square root of x squared minus 1. Well, those square roots, square root and square, so that's just x minus 1. So if we take a look at this next one here, 2x minus x squared and g of x is x plus 1, find the function defined by h of x equals, so our inside is that g of x. So I'm going to do f of x plus 1. So I go to my f function, so it's 2x plus 1 minus x plus 1 squared. And then we could multiply this out. So this first one is 2x plus 2. And let's see, what is x plus 1 squared? X plus 1, x plus 1. So that's x squared, 1x, and 1. So minus, that entire thing would be x squared plus 2x plus 1. So if we distribute that negative, we'd have minus x squared minus 2x minus 1, which would simplify to negative x squared. Let's see, 2x and minus 2x is 0, and 2 minus 1 is 1. So now what we're going to do is we're going to talk about the domain of a composition function. So to find the domain, you have to consider the restrictions. You have to consider the restrictions on what you're inputting, and then you have to consider the restrictions on your output. So if I look at problem number 1, again, we had f of x equals x squared plus 1, and g of x equals the square root of x. And then we said f of g of x equals the square root of x squared plus 1, which is just really x plus 1. So we first look at our input. What are our restrictions on g of x? Well, a square root has to be greater than 0. So we would say x has to be greater than 0. And then if we look at the bottom one, x plus 1, well, there's no restrictions. So our only restriction is that x would have to be greater than 0. Because again, you have to check your input and your final function. So if we look at this second one, it says find f of g of x. And I tend to write it like this. So this is f of x squared minus 8. So if I plug that in, that's a square root of x squared minus 8 minus 1. So what are our restrictions? Well, our input, there was no restrictions on x squared minus 8. That's our input. That could be all reals because that's just a parabola. But what is our output? What is this? Let's see what this simplifies down to. Well, this is really x squared minus 9. So our output, what do we know? Well, a square root has to be greater than 0. So plus 9, what's underneath there? So we have x squared has to be greater than or equal to 9. And then it gets a little tricky because when we square root, there's always positives and negatives. So this would be x has to be greater than or equal to 3. Now, when you think about it, that's positive values, right? That's like 3, 4, 5. But it's some number squared. So that's also negative 3, because negative 3 squared would be greater than 9, negative 4. So we have these two spots on the number line that works. So it could be negative infinity to 3, and then again negative 3, and then again from 3 to infinity. So let's see what this next one would be. G of f of x. So g of the square root of x minus 1. So that would be the square root of x minus 1 squared minus 8, which is just really x minus 1 minus 8, which is really just x minus 9. So what are our restrictions? Well, the output doesn't have any, but our input, the square root of x minus 1, has to be greater than 0. So we square it. So x minus 1 has to be greater than 0. No, I did that wrong. Sorry, I should have just said what's underneath the square root has to be greater than 0. So x minus 1 has to be greater than 0. So x has to be greater than or equal to 1. It should be greater than or equal to 0. And then the last part we're going to take a look at today is how do we decompose these? Well, we're going to try and find the two functions. So what's our outside function and what's our inside function? Well, I see this gigantic square root here, so that's got to be our outside function. And then what's on the inside would be x cubed plus 1. So this one we have a fraction. So our outside function must just be 1 over x, and our inside would be x squared plus 1.